Alright, so we've got a problem here that was commonly missed one on our problem set. This one has a railroad track and a road cross at a right angle, so I'm going to go ahead and get a drawing started here. Alright, it says an observer stands on the road 70 meters south of the crossing. Alright, so I'm going to go ahead and put a person here, 70 meters south. Then it says, and watches an eastbound train. Alright, so traveling east at 60 meters per second. At how many meters per second is the train moving away from the observer 4 seconds after it passes through the intersection? So I'm going to put the train, it was eastbound, so I'm going to put it over here to the east. And I'm just going to put it at a random distance because we know it's traveling that way, so we're going to be looking at some point like this. Now, what I've got here is I've got a right triangle formed. Alright, and the question says, at how many meters per second is the train moving away from the observer 4 seconds after it passes the intersection? So in our find column, we're going to have dd dt, specifically when t equals 4. Alright, and d is going to be this distance here between the person and the train itself. Alright, we're going to have an x value here. And then the other side's y, but reality is it's fixed at 70, so we're just going to leave it at a 70. All right, we know dx dt, because that is our speed of the train. All right, and it tells us this train is traveling at 60 meters per second. So 60 meters per second here. And now relationship is going to be Pythagorean. All right, so this is a related rates problem, and it's one of our Pythagorean theorem problems. So we have 70 squared plus x squared equals d squared. All right, so if I go through this, 70 squared is 49 and then 2 extra zeros at the end, so 49,000 or 4,900 plus x squared equals d squared. I'm going to go ahead and take the derivative of that with respect to time. So the 4,900 disappears. I've got 2x dx dt plus 2d dd dt. All right, I know the speed of the train is 60, so I've got 2x times 60, right, equals 2d dd dt. All right, so if I clean that up a little bit, I've got dd dt equals 120x over 2d, which is going to be 60x over d. All right, now it asked me after 4 seconds. So at 4 seconds, I've got 4 times 60 is going to be the amount of distance that the train has traveled. So 4 times 60 is 240. So I know that the distance on this side would be 240. All right, that's my x value. And then I'm going to have to use Pythagorean theorem working around the outside, where I've got 70 squared plus 240 squared equals d squared. And I'm going to have to solve for d. All right, now with our Pythagorean theorem or special right triangles, we get that this side is 250 at that moment. So again, the two circled numbers we can always only put on the graph after we've gotten to one fixed point. We have to find the relationship between the derivatives first. So now I'm going to plug in the information I know. I've got dd dt, specifically at t equals 4 seconds, is going to equal 60 times our x value, which is 240, divided by our d, which is 250. All right, and I can go ahead if I wanted to. I could cancel out a 0 in here. I'm going to go straight to the calculator. We've got 60 times 240. That gives me a 14,400. I'm going to divide that by 250, and it gives me 57.6. All right, so 57.60. Because it was 57.6 exactly, would be our dd dt at t equals 4, which is choice A. So A would be the correct answer on that one. I hope that was helpful. Thanks.